So now let's look at a definition of the normal distribution. The normal distribution is a symmetric, bell-shaped distribution with a single peak. Its peak corresponds to the mean, median, and mode of the distribution. Its variation can be characterized by the standard deviation of the distribution. Let's talk about some properties of this distribution. We're going to concentrate, find out as much as we can about it, because this distribution is used for a lot of applications, and in this unit we're basically going to learn as much as we can about it and see how it's applied to different situations. The shape of the distribution has three very important characteristics. The distribution is single-peaked. Its mode, or most common birth date, remember that example of the birth date, is the due date. The distribution is symmetric about its single peak. So its median and mean are the same as its mode. The median is the due date because the equal number of births occur before and after this date. The mean is also the due date because for every birth before the due date, there's a birth the same number of days after the due date. And the distribution is spread out in a way that it makes it resemble the shape of the bell. So we call it the bell-shaped distribution. Okay, so we see that its single peak is symmetric, the mean, median, and mode values are the same. Now there's another characteristic that describes the normal distribution curve, and that's the standard deviation. Notice both of these figures represent a normal distribution. They have the same mean of 75, but they look different because the distribution of the left has a larger standard deviation than the one on the right. That means that the values in the histogram in the distribution are more spread out in the figure on the left, and they're closer together, closer to the mean on the right. The normal distribution, and see how this relates to relative frequency. The area that lies under the normal distribution curve corresponds to a range of values on the horizontal axis and the relative frequency values on the vertical axis. Because the total relative frequency must be 1, the total area under the distribution curves is also equal 1, or 100%. Basically that means that 100% of the values that you're interested in are under the normal distribution curve. The percentage of the total area in any region under the normal curves tells us the relative frequency of the data in that region. So if you look at this figure, again this describes the days before and after the due date for the example with your friend giving birth. The total area under the entire curve equals 1, or 100%. That means 100% of the possible values are included under the curve. Now you can break this up into different regions, and different regions tells you, you can figure out the percentage of births that occur in each different region. For example, this region here has about 18% of the total area under the curve. That means 18% of the births occurs more than 2 weeks before the due date. This region right here has about 12% of the total area under the curve. The relative frequency is 0.12, so it means that 12% of the births occur more than 18 days after the due date. Okay, so that's sort of some ways that normal distribution is useful. If you can figure out what percentage each region of the area under the curve represents, then you can analyze the information and make decisions using this normal distribution curve. Okay, here's an example of how you can use this. Let's estimate the percentage of births occurring between 0 and 60 days after the due date. Okay, 60 days is a huge amount of time after the due date, so probably there's 0% that birth occurs 60 days after, but let's see the percentage of births occurring between 0 and 60. About half of the total area under the curve lies in the region between 0 days and 60 days. This means that 50% of the births in the sample occur between 0 and 60 days. So 0 days is the center, and notice 60 days is a long way away after the center, but because this is a symmetric distribution, if you draw a line through the center, it divides the area in exactly half, so 50% of the births occur between 0 and 60 days. Now let's estimate the percentage of births occurring between 14 days before and 14 days after the due date. The normal distribution curves showed that about 18% of the births occurred more than 14 days before the due date. Now, because the distribution is symmetric, about 18% must also occur more than 14 days after the due date. So you can divide up the area into 18% before, 18% after. So that means 36% of the births occur either more than 14 days before or more than 14 days after the due date. And because the whole region must represent 100%, you just subtract 100% minus 36%, gives you that 64% of the births must be between 14 days before and 14 days after the due date. Alright, we're going to stop with this example, and the next video will show more information.